Okay. Yeah. What they say when what Murphy's law, whatever can go wrong will go wrong. Right. Okay. So yeah, I do believe that if the x's are up here, then that is fine. But when the x is down below, okay. Okay, I think I know what went wrong. So let's say you had 55 over 2x equal 5, and I wanted to do it that way that I did before. Okay, alright, I see. So what if this was 55 maybe that's what that was. Maybe. Yeah, I think this is closer to what it should have been. So what I was doing before, this is what I was attempting before. Okay. That's what it should have been. So it should not have been 55 over 2 in front of x. It should have been 55 times 1 over 2x. Okay. Okay. Alright. That's what it should have been. So yes, the answer on the left is 17 over 11. While this don't look the same, you divide this by 2 and this by 2, you end up with 17 over 11. Now, if I multiply 2x by both sides, I end up with 2x times 5 equal 55. So let's write that down. Let's write that down. So I would have 2x times right, that's what that would have been. So it would have been this. Can you divide both sides by 5? So therefore you'd have had 2x equal 11. Right, okay. Alright, yeah. All of that makes sense now. So therefore, the x being down here is just as important as the x being up here. So this is the same as 36 times 1 over x. This is the same as 17 times 1 over 2x. So therefore there's a major difference between those two. So that is important. So if we know the difference now, yeah, we're in a good place. So therefore, we pay attention to where the x is. The x is down here, we'll be mindful of it. If the x is up here, we'll be mindful of that. Yeah. Alright, so now we're done with the first. We're done with the first 4. So now we're going to go to the other 4. I don't think these are going to be as difficult though. Alright. What did I do with my eraser now? What am I doing with it? Oh, okay. Alright, so the next one is going to be x over 5 minus 3. X over 10 plus 4. X over 10 plus 4. And then now, so now we're at number 5. We're at number 5. Yeah, I need to make sure that my phone never drop like that again because the sound still traumatized me. Oh Lord. Yeah, no. So again, you know what we can do? We can make this. Seeing that the LCM of 5 and 10 is 10, we might as well make this, multiply this and this by 2, so it becomes 2x over 10 from early. So why not do that? 2x over 10. And then of course we add 3 to both sides and we minus x over 10 from both sides. So I can write it. So what happened was this. And then of course what also happened was, well, we did that first, right? So 3 minus 3 is a 0. And now the next thing we did was this. Alright, so that leaves us with what? Well, assume that there's a number 1 in front of the x. So 2x minus 1x is just 1x, which is just x over 10, right? So we'll have x over 10. That is equal to, there we go, 7. And no. We multiply both sides by 10. And that's easy, right? X is equal to 70. Now let's see what happens when we substitute the 70 up here. 70 over 10 is what? 7 plus 4 is 11. So the right side is 11. Alright. Now, this was what? 7. This is what? 7 plus 7. Right? Because if I multiply this by 2, 2 over 10 is the same as what? 1 over 5. Right? Or 70 divided by 10 give me 7. So 70 divided by 5 must give me twice that amount. So this is going to be 14. 14 minus 3. Yeah. This is going to be 11 too. Yeah. So therefore our value here, x equals 70, is actually correct. So this here is our x. This here is our 70. Yeah, that never, wow, that, yeah. We're not even need to do too much with that. We're done. We're done. Like that, we're done right there. So we're done. We don't have to do nothing else with that. Alright. To try again. We have 2x over 3 plus x over 9. No, the LCM of 3 and 9. If you have a choice between a house and a room, you're going to buy the house over the room. Our house have a room already. This have that room in here already, so we don't need a room there because we have a house. Therefore, the LCM of 9 and 3 is what? 9. Right? LCM of 9 and 3 is 9. Therefore, we want the denominators to be 9. So multiply this and that by 3. That can be multiplied by 1, which means it not change. So that's going to be 3 times 2x, 6x over 9 plus x over 9. No. 6x over 9 plus x over 9 equal 42. Alright. Now, again, I used to get confused with this. 6x plus x. I used to just write back 6x. But in reality, you put what? 1 in front of that. Now, that means you can clearly see what is happening. 6 plus 1 is equal to 7. So you have 7x over 9. Now the important part is where the x is. If x is up here, then it is 7 over 9 times x. But if the x is down here, it's a different thing. Right? So for example, where the x is very important. Right? So if I had this, that is not the same x. That would have been what? 7 over 9 times 1 over x. That is what that is. Right? So, what that now, yeah, we have to make that quite clear. Right? 7 over 9x is 7 over 9 times 1 over x. However, if you have 7x over 9 now, this is the same as 7 over 9. And if we're being accurate, we'll call it 7 over 9 times what? X over 1. Right? So where the x is very important. Right? So when the x is up, it's x over 1. When the x is in the denominator, it's 1 over x. Right? So now we'll know when to do the appropriate thing. So now we can call this 7 over 9 times x. So we can multiply both sides by 9 over 7. Alright? So again, for the mental note, 7 over 9x is And then of course, so that's also a note to self, right? That is also a note to self. So where the X is important. If the X is down here, the X is down here. The X is up here, the X is up here. So the X being up here is X over 1. The X down here is 1 over X. Alright? So I'm rectifying, right? So we just want to be mindful of that. So with that in mind, can multiply this by 9 over 7. That by 9 over 7. These cancel, leave you with just X. And this would be so therefore our answer for X is going to be 54. Okay, so let's see what happens when I put that up here. 54 over 3. What that now? 2 by 3 by 3 by 3. One of the trees go. 2 by 3 by 3 is 18. Alright, so that means that we have 18 times 2, 36. Okay, we have 36 on this side here. This over 9 is what? Well, it's 6. 36 plus 6, yeah. Yeah. So 36 plus 6 is 42. Alright? So if we substituted this, we'd end up with this, resulting in that. Yeah. So that one never too bad. Alright, so we're done with, well, this is number 6. And I never number it, so I apologize. So I can even do that. I can do that. Watch it. We can do that. There's our number 6. So now we're going to move on to number 7. What is this one? What name? 4x over 7 minus 5. And that's equal to 1 minus what? Okay. Okay, there we go. Let me get rid of this. Okay. Alright, so as usual, we want to be careful. We want to know that we have the right signs using. You can do that one at a time if you want to feel confident about it. This is a minus sign. You get rid of it by using a plus. And, you know, sing the Sizzler song if you want to remember. I've got to take myself away. Yeah? Yeah, man, you have to take away yourself. Because this is self, take away yourself. So, there we go. So we're going to add that self now over here. Alright? So you do to the right, you do to the left. No. Because you take away yourself, When you look at this, that is equal to just 1. 1 minus 0 is just your 1, right? Just the 1. So therefore, you have 1 right here. But just so that I don't lose sight of the original question, I'll put it back. So now what we have left now, we have to add 5 to both sides, right? Again, you know, got to take myself away. So we do that. So now, where are we at now? 5 minus 5, yeah, that cancels. So now we have 4x plus 7. I mean, 4x over 7 plus 3x over 14. 1 plus 5, there we go. Now, the LCM of 7 and 14 is 14. Right? You have 7 and 2 by 7. And just so you understand what I'm saying, right? So here we are. This is down here. So therefore the LCM of 7 and 14 is 14. This needs to become 14. Multiply this and this by 2. So you'll have 8x over 14. So this will become 8x over 14. Add numerators, you have 11x over 14. And remember, the x is up here, not downstairs, so it's 11 over 14 times x over 1. So therefore, it is safe for us to multiply both sides by the inverse, which is 14 over 11. So multiply this by 14 over 11 and this by well, that's not what was expected. So x is going to be equal to 84 over 11. Really? 84 over 11. Let's talk about that. 84 over 11. Will that even work? Will that even work? Yeah, that's going to be a long proof. But I'm a bit confident that this works. But it's one of them messy fractions. This messy. 84 over 11. Yeah. Okay. It's a messy one. It's a messy one. So you know what? We're gonna go to number 8. I will come back to proving that this is correct. You know, so let's go to that. What's this number here? What does it say? X over 3 plus 6 equal 3x over 7 plus 4. Okay, let's move on to that. Three x over 7 plus 4. With the x over 3 plus 6. Oh, okay, this is okay. Alright, this one missing now. So we have to be careful. We have to be careful. So Let me minus 4 from here and minus 4 from here. So now I will have x over 3 plus 2 is equal to 3x over 7. Now let's make sure that everything worked out the way it was supposed to. 6 minus 4 is 2. 4 minus 4 is 0, 0 plus that. Right? Okay, that good. Yep. It don't make no difference. It still going to end up with a minus 2. Right? If we know minus 3x over 7 from both sides, we end up with this. If we did that, that's what we get. So 3x over 7 minus 3x over 7 is 0. And then of course, you know, this is all of that right here. Now we have to minus 2 from both sides. So now we have x over 3 minus 3x over 7 equals 0 minus 2, resulting in minus 2. Right? Yeah. The LCM of 3 and 7 is 3 times 7. Both numbers are prime. Therefore, we have 7 by x and 7 by 3, resulting in 7x over 21. So let's change this to 7x over 21. Three times 3x and 3 times 7. So we'll have 9x over 21. Okay. Nine minus 7 is 2. 7 minus 9 is the same 2, but it's a negative sign. Minus 2x over 21. That's what we're going to call this. Minus 2x over 21. Alright, let's do that. Minus 2x over 21. Uh-huh. Yes. Yeah, me. Yeah, I had an environmental accident a while ago. All right. Yeah. So again, the x is up here. So it's not 1 over x, it's x over 1. So because it's x over 1, you're multiplying this by x, yeah? So it's not being multiplied by 1 over x, it's being multiplied by x over 1. So therefore, you can multiply both sides by minus 21 over 2. So let's do that. Multiply both sides by minus 21 over 2. So minus 1 times 20, let me say it again. Minus 1 times minus 21. And minus times minus, you get plus. So therefore, you're going to have a positive 21 on that side. Right? Or minus 21 times minus 2 is a positive 42. 42 over 2 is a positive 21. So 2 over 2, 1. 21 over 21, 1. Everything cancel. 1 times x. You just have x. So answer right here. Yeah. That go be 21. Put 21 up here. 21 over 3, 7, 7 plus 6, 13. 21 over 7, 3. 3 times 3, 9, 9 plus 4. 13 again. So therefore, the left is 13. The right is 13. So yeah, x is 21 both times. Yeah. Alright. Yeah. Hold on. What am I do with this now? Let me move. Dear God. I swear, I had to pick the worst of the lot. I had to pick the worst. Alright, we'll move it to number 9. Let's go to number 9 now. Let's go to number 9. Number 9. Oh God. X minus 5 over 4. Minus 7 equal x over 5. This is number 9. So my question is, yeah, this one not too bad. To be fair, it's not too bad. So the first thing we're going to do, birds of a feather. The fractions go together and we'll put this number over here. So again, you have to take yourself away, right? You want to get rid of the 7? Yeah, sing the Sizzler song, right? Take, yeah, yourself away. Alright, cool. So what you do to the left, you do to the right, yeah? So that's an easy 7 minus 7. 0 plus this. You're left with that right here. Then, you know, you just have that right here. Alright, so 7 minus 7, 0. 0 plus this will give us what we have right here. And then we have x over 5 plus 7. And then again, we have to take yourself away, right? We want to get u over here, right? So what we do to the right, we do to the left. Right? So 7 minus 7, that's a 0. X over 5 minus x over 5, that's a 0, right? So what we have is this. And that's of course if you want to be careful. Right? So that way you know that you did the right thing. But sometimes you can literally write the wrong sign and all of that. So, you know, better to be safe than sorry, right? So that's why I did that. Yeah, you can multiply all of this by 20 if you want it. You really could. You really could do that. You know, multiply all the left by 20 and all the right by 20. I believe it comes out the same. That was a trick that I learned when I was, you know, teaching a little bit of pre-calculus in university and that sort of thing. But yeah, let's see what happens. Yeah, the LCM of 4 and 5 is 20. So let's multiply all of this by 20 and all of that by 20. Alright, let's see if that solves our problem. Because otherwise we're gonna end up with the same thing. So now 20 over 4, that leaves us with 5 times the x minus 5. Alright? So that's what would happen here. Yeah? And call this a minus 4 in front of your x, you know. And then of course that's a 14 with a 0 behind it. There you go. Yeah, it would have worked out the same. It really would have. Because even if I found that the LCM was 20 and I decided to do this, yeah, it works out to be the exact same thing. Because what would have happened is this would have been 5 times x minus 5 minus 4 times x all over 20 is equal to 7. Then you multiply both sides by 20, resulting in this. So yeah, this actually saves some time, believe it or not. So yeah, never doubt this. If you get to this point, you can actually take the LCM of these two numbers and multiply it by all of this and multiply it by what's on the right as well. Yeah, it will work out. It will work out to be, yeah, precisely what you need. Alright, so now we have 5 times x and then 5 times 5, so we have 5x minus 25. That's one of the nice things about 5. You almost know exactly what numbers to expect. Something 0, something 5, something 0, something 5. Right? So you don't, yeah, you don't be making mistakes when you multiply by 5. Rarely. Oh, I mean, this is 4 times x, so I don't even need the bracket there anymore. And then birds of a feather, 5x minus 4x. We're just left with x minus 25. Or 1x minus 25, which is the same as x. So, we have our x minus 25. Now we only have one thing left to do. We add 25 to both sides. That's it. So we'll have a 25 here. And a 25 there. Now to answer that question, if we're being literal, if we took 25, sweets out of our box and we're left with 140, what was the original amount? The original amount, if you were to throw them back into the box, that's what you're doing. So we're adding the 25 back to the 140. So we know that we originally had 165. Yeah. If we divide it by 5, that would be 31. Right, so the right side will be 31 if I substituted 165. Let's do this again. 165 over here. 160 over 4. Oh, lies, not 31. Hold on, let me do that again. 165 over the 5. Right, yeah. That's, you see, mental maths, yeah, just literally write it down. Because sometimes you're thinking of a number and it's kind of crazy. The left and the right side are both going to be 33. Right? Because 33 times 5 is 165. You put 165 over this. Yeah? 33 times 5, 165. Cool. If I put 165 here, that minus that 160 over 4 is 40. 40 minus 7. There we go. Yeah, so both sides are 33. So therefore, we can say with confidence that x in fact is 165. It is in fact 165. Yeah, all right. Alright, now we're going to number 10, number 10, number 10. Alright, number 10 look crazy. Let me see if it actually is. Is number 10 actually crazy? Let's see. So what we have for number 10 is I just need to make sure that I'm looking at the right thing. Is it minus? Yeah. Alright, we have that. And then we have, is it plus or lies? It's not even a plus. Look at that. It's an equal sign. Look at that. What number is that? Right. Okay. There we go. Alright, fine. Yeah. Alright. So, this is what I would do. Even though I have this and I have that, I want to make this, let's make this a singular fraction. If I multiply this by 5 over 5, I will have, so this is the same as 9 over 1, right? So that's 9 over 1, and we'd multiply this by 5 over 5. So that would be 45 over 5 plus that number right there, right? So this becomes 3x plus 1 plus 45 over 5. Now, if we're grouping like terms, why don't we have them share a denominator? Right? So all of that is shared with 5. And there we go. Now we can group 1 and 45 together because what? They're both whole numbers. So we have 3x plus 46 over the 5. Yeah, so we made quite a few changes in a short space of time, right? Yeah. And then now, what we can do, similar to what we did before, we can multiply both sides by the LCM of 3 and 5. We can do that again. Whether there's a plus sign, minus, or equal, we can do that again here. Yeah, the effect works. Because if you multiply this side by 5 and this side by 3, or no, lies. You multiply this by 5 and this by 3, you end up with the same thing. Because 15 over 3 is 5 times this, and then this will be 3 times that amount. But we'll do it both. We'll do it both styles to see which one of them, you know, what we actually get. So okay, let's do it one at a time. I'll multiply this by 5. Then I'll multiply this by 3. So therefore I end up with this. $15 over the 3, 5 times that. Right. See? That's why it works out to be the same. Because if I multiply this by 5, I multiply this by 5. Yeah. And then that by 3 and that by 3. See? That's why it works out. Because I can't multiply this by 5 and not multiply that by 5. So it worked out. It worked out. It worked out to be exactly the same. Yeah. So, just to save yourself a time, multiply both sides by the 15. Because otherwise, let's do it the normal way, right? If we were to cross multiply, we're multiplying 5 by that. And we're multiplying 3 by that. So you'd end up with 3 in front of 3x plus 46 and 5 times right? So that's one way of looking at it. But then if you multiplied both of them by 15, what would happen? If you multiply this by 15 and this by 15, 15 over 5 is 3 times this, and what? 15 over 3 is 5 times that. So whether we want to cross multiply, which is the normal way, or we multiply both sides by the LCM, we get the same thing. So the safest thing to do, once you have this, you can cross multiply, or you take the LCM, whatever that is, 3 and 5, that's 15, you multiply it by the left, multiply it by the right. Whichever way makes you more at peace. So this will be 10x minus 1, and this will be 9x plus what is this now? This is going to be 138. Then of course 10 times x is 10x. 10 times 1 is 10. I know this is a breeze. This is a breeze. So what we have here? We have 10 here. 10 here. So we have 10x equals that right there. Then we minus 9x from both sides. So our 1x or just x is equal to 148. Now could we prove this? Yeah, but at this point, why would I want to do that now? I mean, it will work, you know. 148 multiplied by 3, add it to 46, divided by 5. Let's see. 147 times 2. What is that again? 147 times 2. 147 plus 147. That's 294. $294 divided by 3. Alright, let me actually do that. So you have a 9 there, 27 from that. Ah, okay. $147 times 2, 294 divided by 3. So the left side is 98. Okay, let me write 98 here. Then, Jesus, 148 times 3. All right, let me do that. Let me not be lazy. Let me write 148 times 3. Let me do that. 148 times R3. That's all. Really? Okay. That was not the number I was expecting. So 3 is 24, 2 plus 12, we have 14. Carry the 1, 3 plus 1 is 4. Okay, 444. Yeah, and we have so we're gonna add that number, 444. We have to add that to 46. Alright, so 444, we add that to 46. And what number is that? That's going to be 490. So that number now you divide by 5. That number you divide by 5. Yeah, it work, you know. It work. Okay. And how we prove that? If I take 98 and I multiply it by 5, I end up with that number right there. Yeah? Because 980, if I divide that by 2, must come up with 490. 490 plus 490 is 980. So if I take this, multiply by that, I end up with that. Or, let me just do the boring thing. So we can't have anything right there, right? Now this is greater than 45. So you have a 9 right here. 49 minus 45. Okay. You're going to have a 4 right there. Well, that's equal to exactly. Yep. And therefore, yeah. Okay, yeah. So that work itself out. So I'm going to move on to the other one now. So this one is 2x minus 3 over 5 plus x over 4. And that's equal to a 2. Alright, oh, right, I forgot to get rid of the rest of that. So yeah, the answer for the previous one was 148. Which number we reach now? I believe I'm at number 11. Yeah. Alright. Again, the LCM for this is going to be, I mean, you can have fun with this. You can have fun with this, right? You can take this, multiply by that, this multiply by that, right? Put it over 20, right? Or you can multiply both sides by 20, and it come out to the same thing. Come out to the same thing. So multiply this by 20 and multiply all of this by 20. So 20 times x is 20x over 4. This is going to be 5x right here. That's going to be 40 right here. 20 over 5 is 4. 4 times 2x minus 3. So this will be 4 times 2x 8x 4 times 3. Okay. So now what we're doing now, you know, birds of a feather flock together, right? These are already here, you know, so we're not to worry too much about that. You know, and there's a plus sign, so it's not that, you know, it's not that crazy. So you know you're going to have 8x plus 5x. So you can, you know, this is your friend and this is not your friend, and you don't want your friend sit down away from you. So you want your friend closer to you. You want, and you make sure they move with them baggage as well. This is your bag, the plus sign of 5x, and this is your bag, the minus sign of 12. So you flip that around, right? Yeah, the like terms right there. So letters with letters and numbers with numbers. This number lonely. This number lonely. Make we reunite them. Yeah, man. Reunite them. So take yourself away and do that over here. I'm surprised I got that number. 52? 52? Alright, whatever. So 12 minus 12, 0, 0 plus this is 13x. And that is 52. Alright, yeah man. Yeah man. So now we divide both of these by 13. (26 plus 26 is 52. 2 plus 2 is 4. Therefore, x is equal to 4. Alright, so our x right here is equal to 4. Yeah. Now what does that look like over here? 4 times 2 is 8, minus 3 is 5. 5 over 5 is 1. 4 over 4 is 1. 1 plus 1. There you go. Yeah, that one there. Never too hard. So, we're done with number 11. 11 done. Done with that, done with that, done with that, done with that, done with that. Number 12. What'd it say? 5. Let me just write y instead. 5y minus 2 equal. What is going on? Why am I doing that? Equal what? Oh, this one. Okay, yeah, this one. You have to be careful with this. This one you have to be careful with. You have to be careful with this. Oh, okay. Yo, TikTok is such an informer though. I can't be bothered. I wish I cared, but it's fine, it's fine. Okay, oh, but this is not too bad. You see, alright, this will make life nice, right? This is a minus whatever this is over here. Right? Whatever that is. And this is a minus right here. You see, because they both have the same sign, you're going to get rid of them in the same way. Right? So, you want to get rid of the minus 2, you use plus 2. So if I want to get rid of this, I have to write plus myself. Take myself away. Right? So we do that to here, we do that to here. So when all is said and done, we have 3y minus 4 over 5 plus 5y minus 2 equal 2. So this green here is the same as this. So we took this and we placed this beside the 5y minus 2 that was up here. And then by adding this to both sides, that minus itself is 0, and you add 0 to 2, leaves you with just 2 over here. Now you want to get rid of this 2, so what you do? You take yourself away. Oh, finally you want to work? Alright, hold on there. Yay! They prove that I'm human after all. Alright, so left is that, and the right is that. Let's call it reciprocity, yeah? If the left gets plus 2, the right gets plus 2. So therefore, just like this, 2 minus 2. So therefore, 2 plus 2 on that side is 4. And we have this over here. Now, fine. We can call this something else, right? What we can call this? We can call this 5y over 1. The reason why we can do that is because when we divide it by 1, it remains the same. But I want 1 to become 5. I have to multiply this 1 by 5. So I need to multiply this by 5. Then do that up here as well. This by 5. Alright, so we have 25y over 5. Okay. And again, we're grouping like terms, right? So we're talking about that. So fine. Now they're all over the same 5. Plus sign here, so right, so 25y plus 3y. So we can put them together by doing this. If we do this and put the minus 4 upon the other side, then you can see it a lot clearer, right? So now this becomes 28y minus 4 over 5. Let me see something. Drop that there. Yeah. No. Every time I have a fraction, this part is the part that gives it a problem. So we want to get rid of the problem. Right? So to get rid of this downstairs, we put it upstairs. So we multiply this up here and that up there. So now we have what? Right? So we have 28y minus 4 is equal to 4 times 5, which is what? 20. So we're going to have 28y minus 4 equal 20. And as usual, my favorite thing to do, you know, even if it's primary school, it's fine. If I took 4 things out of a box and there are 20 left, how many things did I originally have? If I add the 4 back to what's in the box, end up with 24. So now we have 28y is equal to 24. Yeah. So let's write that. 28y is equal to 24. So we get rid of what we multiply by dividing, because we have 28 times y. We divide this by 28, that by 28. And if we want to reduce that fraction 24 over 28, well, let's see. So the prime numbers of 24 is 222 when multiplied by 3 and 22 by 7 for the 28. We are going to eliminate the HCF of the two. The HCF of 24 and 28 is going to be that's going to be 2 times 2. Therefore, 24 over 28, when simplified, y is equal to 6 over 7. And that's what I like about using prime numbers, right? We don't make any mistakes. We reduce it to the lowest possible term by eliminating every, we don't even have to guess. We're not even guessing. So 24 over 28 in its lowest terms has to be 6 over 7. Right? Yeah. Yeah, but now for me to go and prove this now, what's that? 30 over 7 minus 14 over 7. So therefore the left hand side is going to be 16 over 7. Alright? So this should be 16 over 7. That's what it should be. Now, what happened when I put that over there? Lord God, alright. So, so let's do this. We have 18 over 7. That's okay, that's interesting. 18 over 7 minus 28 over 7. Let me write it. Next thing you know, I'm going to make a mistake. We have 18 over 7 minus 'cause if I multiply 6 over 7 by 3, I get 18 over 7. Right? Well, the reason why that's dangerous is because of the minus sign. So in reality, if I have a minus sign here and they're in brackets, oh, hold on. Right. That changes everything. Because that's the thing that I thought was dangerous about this question. When you have this minus in front of the 3y minus 4 over 5, you're literally putting all of this behind brackets. Because you'd have minus 3y minus a minus 4 giving you a plus 4. So that's why this is dangerous. So you have 28 minus 18, which is 10 over 7. Alright, 10 over 7 divided by the 5. Yeah, that's why that's dangerous. Okay. 10 over 7, you divide it by 5, you have 10 over 35. What? Hold on, let me see if it work out. Let me see if it actually work out, because that might be okay, we might be onto something. So let me try this now. We have 10 over 35. 35 over 35 times 2. We'd have 70 over 35. When we do this, right? This is the same as this. This is the same as that. Alright, I forget. You see what I talk about? This is what I talk about. Remember, I had a minus on the inside here. I had a minus on the inside there. 18 minus 28 is minus 10. So therefore this would have been minus 10 over 7. Yeah, the proof is kind of crazy, right? Right, so therefore the inside here would have been a plus. That's what would have happened. Right? That's what we'd get. So that minus 10 over 7, you divide that by 5, you'd get that. Okay. Right, yeah. So this would have been 80 over 35. So if that's 80 over 35, yeah, it makes sense now. All that makes sense now. If I divide this by 5, I end up with 7. I divide this by 5, I end up with 16. Yeah. So the answer is definitely 6 over 7. But yeah. You have to be careful with these minus signs. Because so in reality, what we had was 2 plus 10 over 35. And then you change the 2 into 70 over 35, resulting in this 80 over 35, which is equivalent to this over here, which we got by doing this. 6 times 5, 30 over 7. 30 over 7 minus 14 over 7, just so we know. So if we put that up here, we get 30 over 7. If we subtract 2 from that, this 2 over 1 times 7 over 7 becomes what? Yeah. And then 30 minus 14 leads us to getting 16 over 7. Yeah. Alright, hold on. I'm looking for the rest of the questions now. What am I looking at? Alright, so that's done. That's it? What? What? No. I thought there was more to do. All I done. It done. Oh, I did not know that. We're done. Yeah, I didn't know. I done this so. Okay. Alright, yeah. Yeah, I didn't realize that I did 1 through to 12 already. Yeah. So some were easier than others, right? But yeah, let me give myself the reminder. So let's look at 2 things. 3x over 5 is not the same as 3 over 5x. These reminders Wait, where was that playing from? I don't even know. Where is that? I don't even know where that's playing from. Yeah, nope, I have no idea. No idea where that's playing from. Yeah, anyway, yeah. These 2 things are very important to know the difference of. So when the x is up here, x over 1. The x is down here, 1 over x. So that's important. Can even color it different. We give it a different color right here. Yeah. So this way, whenever you need to do any so if you want to make a comparison and you want to say that let's say you want to claim that this is equal to say 9, then when you do that with this, we have to be very careful with it. Because if we're doing that, it means what we have is 9 times 1 times 3 is 27. No, hold on. Let me say that again. Let's say you were to write it like this. Is equal to your 9. Right. What you want to do is just so we're clear. So you do it one at a time. Do it one at a time so that it doesn't confuse you. Multiply it by 5/3 first. So then you're left with 9/3, 3 times 5, 15. You have 1/1 over x is equal to 15. So then x is equal to 1/15. Yeah, that makes sense. So this is the one we need to be careful of. That one is a little bit more straightforward. Because in this case, you multiply both sides by 5/3 and you end up with x. In this case, you do the same thing, except you end up with 1/x is equal to something on the other side. So then now you have to now you have to solve for x again. And you know what funny? All you have to do is flip this upside down and flip that upside down and you get your answer. So, if 1/x is equal to 15, x over 1 is equal to 1/15. Because this is the same as 15/1. So if you flip that upside down, you flip that upside down. So if you have one, if you know what the value of 1/x is, you know the value of the other side. Flip both of them upside down. Yeah. So this one we have to be careful of. We have to be careful of that one. Because again, this one is fairly straightforward. But this one have an extra step to it. Alright? X over 1, 1/x. Okay, so it might go a little bit dark. Try make an adjustment. But they're not too bad. But I'm looking for something right now. Where can I find that question or the set of questions? Did I put them here? No. Oh, I did. I had something else, you know. Well, fine. If it's not on the phone, we'll have to use a computer for that. Let's see if I can find it. Hold on there. Oh, okay. Alright, might as well go to that since it's helpful. So let's try some of those. I have some of them here too. I have some of them on the phone as well. Alright. So let's go. Alright, so as usual we have something like and they're asking us to make So, what would I do about that? What would I do about that? Alright, fine. Let's do it in the way that I imagine, right? This times this. Now, if I want to get 1 up here on that side, then this side would have to be F2. F2 over F2 would be 1 over the F1. And then same thing here. If I want just the F2 down here, F1 over F1, right? Now watch this. Remember what I said before? Now that I know what 1 over f is, I can find what f would be. So I can just flip this upside down. F is equal to f1, f2 over this. Now mind you, this will be an answer if you are looking for the capital F. Right? Only problem with this is that this leads us into more problems than we needed, right? So really and truly, this works if we're looking for this one right here. And this is why we color code, because what I'm looking for is the F2 and nothing else. Alright? So let me get rid of that. Cause that now gonna help. So what we can do is cross multiply. So we have the only problem now is that this is stuck in the brackets. I have to get rid of the brackets. So now I have to distribute and say that we have this. So, okay, so we'll go over everything that just happened, right? Found the LCM of F1 and F2, right? If we divide this by this, we end up with F2 and put it over here. Divide this by that, we end up with F1 put it over there. So this plus this over that should give us what this was originally. Right? F2 over F2 is 1 over the F1. F1 over this is 1 over the F2. So we made this a singular fraction. Then now, because we have 1 over F, we're going to cross multiply. So 1 multiplied by the... So therefore, what we ended up doing was 1 multiplied by that, F multiplied by that. That's what we did. So the F is multiplied by everything over here. We'll put that in brackets so that it's safe. 1 times this is just, well, 1 times F1, F2 is F1, F2. Now, because we have these, we distribute to get rid of the brackets. Because now we're trying to get these two together again. So we're going to minus the capital FF2 from both sides. Right? So we're going to minus yeah. So just so we have context, this is, oh sorry. Sometimes I forget that I have alarms on my phones. Yeah, sorry about that. So That's what we're going to get. So now we will have them both on the same side, right? So let me change the color of this so that we understand what just happened. So therefore, it's going to be capital F with the blue F2. Right. Yeah. So we'll have that. All right. What else am I looking for now? I'm taking my time with this because I don't want to. Yeah, I don't want it to get messy. So I have an idea. So let's get rid of this, right? Let's get rid of that first. So that will leave us with that on that side right there. And then so this is what just happened. Now, yeah, I think they did this on purpose because them know it would have take more work. Now we're going to factorize. What's common to both of them? What's in blue? What's in blue I go put outside here. That's what I go do. So what's in blue I put on the outside. And that makes this entire thing easier to do now. Because after this, there's only one step left. So now, what is in black, you put in here. All right, good. Yeah. So we have to multiply this by that. Then I have to subtract this from both sides to get this. Then after doing that, I try and take out the F2 out of the two of those. So the only thing left to do now is divide both sides by what is in bracket. So yeah, this one, because you know, here's why it was tricky. There was a F2 up here and a F2 down here. And we had to find a way to get them on the same side. So we cross multiply to see if we can figure that out. So the 1 times this gave us this over here. This times this gave us that right here. So for it to make more sense, I can put a bracket around here. So you take this F and put in front of this, the 1 and put in front of that. 1 times that is just that. So that's how we end up with this. Then you multiply F by the F2, you end up with the FF2, and then this by FF1. Now we kind of skipped a step, at least based on what it looked like now. So we minus black F, blue F2 from both sides, and that's why we have this. So we just have one thing left to do. Yeah. This never did go easy. So let's see if I can make a mental note. Let's do that. Let's put a mental note of that. So the blue F2 is going to be equal to all of that. Something like that. No, to actually prove that, I not do it. That I not do. I refuse. And it can work, you know. Because all you have to do, this is F2, this is 1 over F2. So to get that, you flip this upside down and put it beside that. So if you have F1 minus capital F over, yeah, I mean, so I can show better than I can tell, right? So this is F2 over F1, but 1 over F2 would be this. The F1 minus F that's what that would be if we were to inverse it. Now if you're adding this to 1 over F1, what would happen? What would happen to somehow? Multiply both of them by capital F. Yep, it worked. It worked. It worked. It worked. So, if we multiply this, what would happen there? What would happen there is that we'd end up with capital F so it end up with capital F up here. Over yeah. So then now F minus F then finally, obviously, because this and this is the same, you never need that. Right? Technically, they were all sharing the same denominator anyway. So in reality, that is what we really had. And guess what happened now? This divided by this leaves you with 1. 1 over F is this. So yeah, that actually makes sense. So yeah, that, I'm not gonna lie, that I was expecting it to be a little bit easier. It wasn't. It wasn't. That's question 174. Question 174. And what is... Alright, so we're looking at 179 now. Because this is out of the one of the CSEC textbook name, right? Alright, hold on there. We're gonna do this one, and right now I'm just kind of, yeah. Okay. So let's write what it says. F is equal to one over 4 pi some kind of E then you have this, and these are being multiplied, by the way. All of that is over r squared. So we need to make what are we making the subject now? We are making r. Right, so r raised to the 2. But it's not that difficult. It look hard, you know, but no, it's not that difficult. No. Watch this. So, imagine that this is just Q1, Q2 up here, because Q1 times Q2 times 1 is just that. And then we have this. I mean, it is to some extent, but not really. Now, the reason why it's not that difficult is because obviously now you go cross multiply. So now we're going to have 1 times this, meaning just keep it on this side, it not go change. You have to worry about the Q1, Q2. Now, we're going to multiply the 4 by all of that. I mean, remember 4. The F, yeah. I don't know why I said 4 a while ago. The 4 pi r squared raised to the 2. Now, we want to get rid of everything that's in the black. So we're going to divide, right? Yeah, so we'll divide both sides by what's in black. So we want to get rid of black, we use the same thing up here as down there. Now the good thing is, even though you have r squared, There's only one thing you have left to do. Just one. Right? You just have one thing left to do. So this divided by this. So now we have one thing left, which is to get rid of the exponent, to square root it. I have a square root the left, we square root the right, and that should be it. Alright, the square root of 64 is the square root of 8 squared. The square root of 8 squared is just 8. So the square root of any square leaves us with what is just, yeah, leave us with that. So can I prove that this is right? If you put that here, or oh, yeah, right. So it becomes, yeah, it work out. Because if you put this in here, you square this sign disappears. Q1, Q2 divided by this would end up flipping this up here. So you'd end up with this over Q1, Q2 times this. The Q1, Q2s would cancel, leaving you with this over the 4 pi e. And the 4 pi e, if you divide this by 4 pi e, it leaves you with, yeah. So this is about that bad. It's about, you know, it just kind of looked crazy. It wasn't that bad. All right. But why? All right. Yeah, I had the pictures and then flip upside down. All right, let me see if I can do this one. My eraser, where are you? Okay, good, I found it. All right, so all right, R, big R, big R, big R is equal to, let me just make sure I have the right thing. Okay. Now, what else do I have now? They're asking me to look for. Okay, good. The ones that tend to be troublesome is the ones where you have the same letter up here as you do down here. So the first thing that gives us a problem is the square root, so we want to get rid of that. So let's square this and square that. So now we're left with So we're left with 2x over x plus y is equal to big R squared. Now we want to put the x's together. So we're going to have to what? We have a cross multiply now. So 1 times 2x is just 2x on this side. And then this is r squared times the x plus y. Now so we distribute that. That, okay. Yeah, that I was not expecting. That I was not expecting. Alright, so to be on the safe side, let me minus 2x from both. No, not 2x, sorry. Not the 2x. The r squared x. So let's do that. Minus the r squared x from both sides. There we go. That's what I wanted. So for me, I like having I like moving what I want as my solution. I want it on the left. I don't want it on the right. Now I have that preference, right? I have that bias. So once I get rid of this here, once I get rid of this right here, what I'm going to want to do is I'm going to write, I'm going to put this on the left and that on the right. That's what I'm going to do. So this is r squared y. Let's flip it over now. Right, so now that I've done that, is the x we want, so the x come on the outside. x come on the outside. So now we have 2 minus r squared yeah. So let's see, this is going to be r squared y divided by, so let me put that. So let's get rid of all of that. X is equal to all of that. Alright, hold on, give me 1 second here. And to the left of all of that is our little x. Now that should be it. That should be it. So if I were to remove that and remove this, would it work if I substituted this? Would it work? Okay. Yeah, that look kind of mix up. That look crazy. Oh. So 2y minus r squared y. Okay. So you end up with 2y upstairs. And then you'd have 2r squared y. Yes, 2r squared y divided by y. Alright, hold on. Let me be sure about that. It's more like, no, it's 2r squared y divided by 2y. Yeah. It'll be divided by 2y. That would cancel, leaving you with r squared, the square root of r squared. Yeah, yeah. I mean, I did that in my head. So, wow, like proving this. Yeah. I feel like I should do the proofs another time, cause yeah, that's yeah, we did our due diligence today. Yeah. At the risk of dropping my phone and everything. So anyway, yeah, I genuinely can't believe I finished everything. So I guess now, whatever we're gonna do next, I'm gonna just make a video of that. Because once you know how to do this, every topic that you do becomes easier because of mastering this. Alright, every topic gets easier. So for example, if you are, let's say we Getting rid of this. Let's say you had to do this. And then they told you to make the big A the subject. Then what you do? You put this over here and that over here. So save yourself the problem. So you start with that. You want to get rid of this to the left. So divide this by this. And what you do to the left, you do to the right. Now if you're using a cosine rule or you're doing bearings, you are using this formula. So now and the final thing you do, find the inverse cosine of this, and the inverse cosine of that. And the number multiplied by its inverse is equal to 1. So therefore, when you find so the inverse cosine multiplied by cosine, it leave you with just 1. Anything raised to the minus 1 is 1 over that thing. 1 over cosine times cosine is cosine over cosine, leave you with 1. Therefore, this cancel that. And that is how you end up with just A by itself. That's how you make A the subject of the formula when you're using what? The cosine rule, if you're doing a bearings question, or if you just have to find the missing angle given that you only have the 3 sides. So if you only have the 3 sides and you need to find the missing angle, and they give you all 3 sides, that means you have little a, little b, and little c. Use it to find the angle of big A. Right? So changing the subject of the formula help you in, you know, more areas than one, right? So let's say you needed to do that for, let's say, Pythagoras or something like that, which that not as difficult, because let's say them say and they tell you to find letter B. I'll flip this around. And what I do? What I want, a color code. A color code what I want. A minus a squared from both sides. So now make sure that that look like a So then now I want just the letter B. I square root the left, square root the right. So now on the left I have just B. So one is cosine rule, one is what? Pythagoras. So this way you know, right? If you have, let's say, what? 225 minus 81, what you end up with? You end up with 144. Square root of 144, you get 12. So therefore the B would be 12, right? Whereas before you had one side that might have been the 15 and the other side might have been your 9. So 15 squared, 225. A squared, 81. 225 minus 81, 144. Square root 144, you end up with 12. Right, so that's how you can find the missing sides. What else can I apply this to? To anything, even the most basic, of the, the geometry or whatever it is. So let's say, even something like this, even your coordinate geometry. Then what? Alright, so you want that, so minus C from both sides. And then we divide both. And that's it. Now if you were to put that in here, m times that, it would cancel, leaving you with y minus c. C minus c, that would be equal to y. Y minus c plus c, y plus c minus c, you end up with y. So in any situation that you need, so could even be the one like this. And your job is to find this. So, what you do? You multiply 1 by the PRT, 100 by the I. And you divide the left and right by everything in black. Divide this by what's in black. Divide this by what is in black. So you have 100I over PT. Now, how does that work? 100 over PT times PT give you 100I, 100I over 100, you end up with I. Even for something like, let's say, something like that, and you claim you have everything else except the little a, how would you find that? And imagine that this h is multiplying everything too. So it's like you have h over 2 times that. Multiply both sides by 2. So now you have this. Now let's flip that on the other side and distribute it. So we'd have BH and this right here. Now if I want to get rid of BH, I have to minus BH from both sides. So okay, so we have red letter A, H is equal to all of that. So let's get rid of that. There we go. Now what do we have? We want little a alone. So divide this by what's in black. Divide this by what is in black. So the real question now is, does all of that work? Does all of this actually work? If you take h over 2 and multiply it by that, so it would be AH plus BH over 2. Okay, so that would have cancelled that. 2A over... Yeah, it worked out. It worked out. Because you'd have 2A over the little h multiplied by h over 2. The h's would cancel, the 2's would cancel, leaving you with the a alone. Yeah. So even when you get to the end, you want to be sure that, yeah. And I mean, imagine, this is the area of a trapezium. And it looks so simple, but I'm sure nobody would have tell you that little a would come out to this. You know, unless you actually did the work you wouldn't know that little a would come out to that. You wouldn't know. So that's why it's good to know to change the subject of the formula, because when you get that, if you get that under control, if you know when to square root, when to divide, when to multiply, when to subtract, you're using an inverse operation. When you see the plus, use a minus. When you see a minus, use a plus. Right? And even when you see a letter that is squared, there are times when you will subtract the entire thing because you're trying to move it from one side to the other side. So even though we see the square, it's not every time we see a square we're going to square root it to get rid of it. Sometimes we actually, in the example of this, let me use the blue to make it make sense. So when we add this, when we wanted to get rid of b squared, we minus b squared from both sides. So therefore you'd end up with h squared minus b squared is equal to a squared. Right? So it just depends on the sign that's in front of it. So the sign that's in front of it determines what you're going to use. The sign in front of this is plus, you use a plus. The minus to get rid of a plus. Now it's different if this was, say, you're multiplying. So if I multiply is in front, you divide. Right? So it just boils down to what's in front of your letter and so on. So everybody and me is supposed to tie it by now. So, you know, next time I'll figure out what we're going to do. And yeah. So we'll catch up tomorrow and Thursday too.